Okay, I don't know if I'm online. I've had some issues there connecting this morning. So we will see if anyone can hear this. You'll see I connected and then had some issues and had to reset everything and reconnect. So I will delete that first like 10-second stream or whatever it was, and we'll go from there. So what I was thinking is that we could have a look at some questions we've been getting, and answer your questions live. So if you have anything, please drop it in the live stream comments. I will try to see what I can see. Hey, hi, at least someone can see me. That's good, and I can see your comments coming through. Kanish, great. Good morning, I hope you're well. So open up questions. Any questions you want to go through, anything I can kind of draw on the screen, we'll go from that. It's been a while since we had a live stream. Basically, we got really busy. I've taken on quite a lot more than I thought I was going to take on. We had the arrival of a couple of really big training contracts, which have absorbed a lot. If you follow us on LinkedIn, you would have seen that last week we ran our first drone course, which was quite cool. Now, I'm a civilian instructor for the Sea Cadets. So yesterday we were boating. This afternoon we're doing water safety tests. So it's it's taken a lot and it's slowed a lot of stuff down. But I've kind of rejigged my diary in a way we go again. So we'll get back to these live streams as much as possible. Kanish from India, great. How is it over there? It's been a while since I've been there, but it was great when we were there. So questions. So if I'm going to open up another tab and I'm going to look at to get us started while we wait for the questions to come in. Anything that people have been asking to me in the comments of videos. Because we have had a few. We've had a few on stop starts, a few on different things. So thank you for the amount of engagement in the last couple of videos. I think the multi-choice videos normally go down quite well, which helps. And we can go from there. Right. What we got? Okay. Should we go with some questions on stop starts then? Because we are getting quite a few of them, and I can understand why. The addition of stop start questions is new to CSWIP. It had never really been there in the past. Creator cracks had, but stop starts no. So I'm going to bring up a blank bit of screen so that I can have a look, and we'll see if we can get something on here. So stop starts, the position at which the weld finishes and restarts between weld runs. So the biggest one that this really affects is something like stick or MIG-MAG, where we have a fairly large weld pool, and then that weld pool is cut off really quickly at the end of an electrode or when you let go of the trigger in the MIG-MAG process. Okay, so I'm just going to try and, oh, not that one. Can I do this one yet? Right, so trying to use a blank screen here, and we'll just hide all of this stuff so we can see a bit better. Right, so let's go. I'm going to try and draw with a mouse, and we'll see how good this ends up, right? So if I've got a weld and I'm heading along and I've got my weld and I'm getting my sort of It looks like a really good weld, inconsistent weld in lots of different ways, but I'm heading this way, and I get this circle at the end of my weld. Okay, that is where we've had a big weld pool, and then it's turned off instantly, so all that arc force and everything was pushing the weld out, and it's a big circle. If we turn the power off instantly, it will turn off, solidify with that flat area like that. Okay, then as it cools, it will try to cool in that direction, right? Because the outside will cool first, right? And then in the center, because it's still molten, that cooling gets everything pulled away, and we end up with a crack in the center of that there. Okay, and it's just like making a donut. It's pulling everything from the center out, and then we will go. So we've got our stop start is here, and our crater is here. Now you could have a stop start and not have a crater, but I think you need to have a stop start to have a crater, if you know what I mean. Right, so that's the way it looks. Now, in good practice and all that, what we expect is that, if I get rid of this now, is that when we stop, we should have our weld pool stop position at the end of that weld. And when we restart from at least the beginning of that area here. So when we start welding again, we pull off, and all of that area now becomes weld metal, and away we go. So in our exams, what we're looking for is a area that is flat, where this did not start where we thought it was going to be. Again, drawing with this mouse is a bit of a nightmare. So if I've got my finish from this weld here, and then this weld starts like this, that makes sense. So this area here, this flat bit, that's what we're looking for. And if we've got that, we need then to look for a crater that might be in the center here somewhere. Okay, so that's what it's looking for, because it means that the welds on stepped over each other correctly. It means that we may have a crater crack, but on the other side, on the root side, we may have a lack of penetration, because the weld hasn't had enough time to come through and join up with the end of the last weld before we start going. So a stop start can be on the cap and on the root. And one of the big things to remember here with the new exams is the questions aren't segregating face and root side. What they're doing is just saying, on segment A, what do you have? And all the answers are there for you to put a tick box in, to which stop starts could occur on the face and the root. So you've got to look on both sides and just answer it in one hit. Okay, so there's stop starts. Hopefully the last video we did will answer that in a bit more of a, here's an actual real weld. Go and have a look at that. But just take your time. If it doesn't look like the welds are connecting properly, that might be an area of issue. Okay, cool. Right, so that's that one anyway. What we got next? Questions here on who we got. So Kanisha said, how much time is required to do CSWIP? Oh, okay. CSWIP. You probably depends on your amount of experience, right? And even with a lot of experience, it's a hard course and a hard exam. So when we say experience, got to remember that our experience level doesn't often incorporate all of the theory that the 3.1 requires you to have. Maybe there's a fair point to say that the 3.1 isn't built to test inspectors. It's built almost to start you on the route of welding engineering. So most inspectors, they're out there making decisions on weld quality, but don't interface with, what a constant current is, how defects are actually formed, welding procedures in a how they're built type of area. Okay, so the course, you definitely need to look at what the examination requirements are for CSWIP and make sure you're gaining that during your experiential work. Okay, some people do turn up to CSWIP 3.1s and do it all in that 1 week and learn everything. I think it's very hard to do that. I would give yourself at least, well, I'll tell you what, we can do one better than guessing how long it takes. We can go and look at the CSWIP document, okay? CSWIP scheme document. Right, so again, the best way to do this, right, is if you go to Google and just type in CSWIP scheme document, you're looking for CSWIP-WI-6-92. Okay, that is the scheme document that tells you everything you need to know about CSWIP and how long they say you need. Okay, so if I look at this, here we go. So we've got our CSWIP document here. Here's CSWIP WI-92. So what we have to do is come down. So first it gives you your duties. So when you get in your experience, make sure that you're catching all of this stuff, because this is what the exam really includes. But we want to come down to, there you go, requirements prior to taking the certification test. So the welding inspector is a minimum of 3 years welding inspection experience related to the duties above. So all of these duties here, for senior, which goes up and up and up, right? Okay, so as a very, very quick answer, we can say it's a minimum of 3 years because that's the requirement for CSWIP. Now, there is a different way of doing it. Or CSWIP Visual Inspector for 2 years. Now, again, I'll tell you, if you do the 3.0 to move to the 3.1, yes, you can do your 3.1 a year earlier, but remember, you may not be getting the experience in line with the duties in this document, so make sure you're doing that. Or you're a CSWIP welding instructor or welding foreman. That is like such a small amount of people. It's quite difficult. I don't think I've ever really seen somebody come through that route. Again, the welding instructor and welding foreman have their own entry requirements in their own scheme document. So you go to the CSWIP website and you can get all the scheme documents from there and see how all of these play out. 3 years, but make sure you're gaining the experience in line with the top. You're looking at the theory of how welding sets work, because we know that's a big part of what the exam is, rightly or wrongly. They do want to teach us to be welding engineers a little bit more than inspectors, or get you onto that route anyway. Okay, great. No problem, Karish. That's sorted. Right. So, what's the next question here? Chingabo from Nigeria. Great. Awesome. How you doing, mate? Any videos on CSWIP 3.1 WS exam selection? Yes. So we do have a couple of videos up on the channel, but we also have a package on our website to buy, which has an example of a WPS and a welder qual and some questions. We're trying to do more. I'll be honest, one of the biggest things is to make sure they don't look too much like the exams. I don't want to get into a fight with TWI where they believe we're crossing the line, so we're busy trying to build them to pull it out. But any any questions you have around WPSs, particularly for this session, I can go through. But one of the big things here is just to remember that the WPS questions are exactly the same as the general questions. It's just to give you a document to look at. So one of the first questions in the training scope is about weld positions, and it's basically saying, this is your document. Go and have a look of it. So you get your document out, and it says vertical up. What is the ISO requirement for that? Not to say vertical up. It would be, well, it was PF. You know, if it says vertical down, it would be PG, and so on. So they're not questions where you need to memorize how WPSs are made. It's just how you extract information from a document instead of it giving you in a question, you know? So I don't get too worried about the WPSs as long as you can find the right document. And that's one of the biggest things. They give you a lot of documents, you know, almost like 12 pages or something like that. Then we should be all right. But any direct questions, I'd be happy to answer. Okay, Lex. Good morning. I'm always grateful for the videos you put on. I get so much explanation answers in them. Please, can you help? Okay, right. Yes, I tell you what. Ask me. I need to know what you want to know about the WPSs so I can directly answer them. Right. So please do that, and we'll discuss it. Sean, James, I've just completed my free 10-year renewal. 78% of my practical. I only got achieved just over 40% of the exam. iPad change samples not a day. Yeah. Okay, Sean, I would. They're not. Yeah. So looking at the samples being chained together, it makes it difficult to kind of handle them. You know, you're trying to look at one sample and there's lots of samples together. I guess we could all see why they've done that, because there's a sample with all of these bits attached to it, and then you can go through it. I think it makes it quite difficult because you've got a sample and you're trying to get the weld gauge onto it, and it doesn't help. It's all out of balance. There's no disagreement with that at all. The iPads, yes, the iPads are a new dynamic to the exams, which again, you can understand why TVY training have gone down that route, because it allows them to potentially process exams faster and get them sorted. If we're not used to the iPads, then yes, I would like to see the iPads being used throughout the training. So when you're doing your samples each day, you're actually answering in the iPads and you're getting instantaneous feedback through that. I think doing them in the books is very, very different, especially when it comes to the acceptance criteria, because when you do them on the paper, they're all together, so you can see your crosses for question 1, 2, and 3. But in the iPads, they come on separate pages, which again doesn't allow you to actively check that you're getting the right answers. And we do see, because they're touchscreen, the iPads, of course, when they go to draw the page up or down to read the rest of the text, it is easy to accidentally click an answer and it changes your answer. So you've got to make sure you're right off to one side to pull it up and down. I personally, at Carbon Arc, we've decided not to really go that way. So when you do a Carbon Arc qual, it'll be on a steel sample as a sample. But we're doing our exams differently, which is like a real exam report rather than multi-choices and stuff, because we want to make sure weld inspectors are welding inspectors, not are IT people who can use an iPad. And I don't know. I don't want to put words in TWI Train's mouth at all. You can understand where they might have seen on their risk review of the new system saying, well, everyone can use an iPad, therefore it'll be okay, which is fine to a point, but the exam interface has to be designed so that it's easy to use. You can have a simple iPad touchscreen and it not be easy to use. So I'm sorry. I know for a lot of 10-year renewals, people have had the similar type of comments because you've been in the industry for at least 10 years. It might be your 20-year, 10-year renewal. It's a nightmare, you know. I've just done my 15-year 3-2 renewal this month, and even just getting the CV renewal was a nightmare. Never mind having to do the exam again. I guess I'm not looking forward to it when I'm in 5 years' time when I have to do my iPad one, and I know how the system generally works, you know. So, yeah, it is another curveball. They could deal with it better, and I guess one of the things here is, do you know when they? So I think one of the biggest problems here is the way that TWI Training have decided to do their feedback nowadays. You used to get a physical feedback form to fill in, one for the training, one for the exam. Now they giving out a QR code where you've got to physically scan it and interact with it. I think that puts a barrier up to feedback, where people then don't go and do your feedback. But honestly, make your feedback in those exams, because any company who doesn't get the feedback in their system is more likely to say something along the lines of, well, no one said this, you know. But they have made that feedback loop quite difficult to actually to use. So for everybody, if you think there's a problem, communicate it with TWI or communicate it with CSWIP. You know, the team at CSWIP are very helpful people. Again, there's so much they can deal with because of the separation of certification body and training body. Okay, but we've got to engage with the process if we don't believe the system's working like it should. Cool. Yeah. So right. So I've got no more questions in the chat. So I'll have a look on my community tab and see if we've got any more which have been coming up. Oh, okay, cool. Just as I was about to do that, thermal cutting processes. Right. So let's see if we can get some interaction up on the for the algorithm then. Right. Name me 2 thermal cutting processes. Lex, you've asked a question. So what's 2 thermal cutting processes? Because we need to kind of be thinking about the difference and how they can be applied. No. As you do that, I'm just trying to look at my community screen and see what next question we've got. So there's 3 thermal cutting processes at least, but we need to think about 2 of them. What are they? And it doesn't matter if you're wrong when you shout out an answer. Okay, so there's mechanical and thermal. So mechanical is like grinding and all that type of thing. Thermal would be gas cutting. So whether that be is oxy fuel really. So the fuel could either be acetylene or propane. You could have plasma, you could have laser, and all of these different thermal processes. So if you think about oxy-fuel, plasma, and laser, they're going to have different ways of imparting heat into the structure. Yeah, they all have pros and cons. You know, oxy-fuel nowadays is seen as a bit of a messy process, as in the cut that is left is isn't always the best. Okay, it's very much a skill-driven process with oxy-fuel. Okay, you get dross left on the part fairly easily, and it melts in a horrible way. The with plasma, we're going to struggle with plasma's a bit easier actually, but there's two different types. There's transferred arc and non-transferred arc. But plasma is a much better all-round process because it can cut any material, right? So it's not reliant on, where oxy-fuel is reliant on rapid oxidization. So rusting, it has to be a steel, a carbon steel. Plasma will cut through everything and generally gives us really good process. So, and then laser, really detailed, really small cutting face, but is limited by thickness. Okay, so if we look at them, my next question would be to say to you, well, if you have these thermal processes laid out, which other pros and cons do you think you would get from them? Okay, generally, I think questions come along the lines of types of material, thickness of material, potential issues. So try and put them down on a board and try and work out how much you know about each of those to get your best answer. Okay. Right. Where are we? Okay, WPSs. Right, WPSs. Ask me a direct question about WPSs. Where are you guys struggling with them? If where do I start? Okay, and where are people feel that they're not getting the most out of the understanding of that part? Because at the end of the day, it is just multiple choices around a bit of paper. Okay. I'm trying to think how best I can go through one of these. I'm just looking what I can bring up. I'm going to see if I can bring up a WPS actually. On the fly, how quickly can I find a WPS in my system, which I can make some quick amendments to see if we can talk about them. You know, for somebody who does loads of WPSs, finding them. Right. So let me just remove a couple of things from this page before I share it, because this is where we go. Okay. Right. Okay, so let me stick this up here. So I'm going to show you a preliminary welding specification, okay? Because at the end of the day, they look exactly the same as a WPS. And we go from there. So let's say that. Right. So here is my preliminary welding procedure spec. Looks exactly the same as a WPS. This is my layout for one. So, you know, all WPSs look differently. Don't worry about that. It's about finding the information that we need to find as easily as possible. I haven't got a joint design in here, but that could be one of the questions. So WPS is always laid out with, somewhere on it, company information, you have the information about the WPS that you're applying. You need a WPS number, so I don't know, we'll put a number in there. We have a revision. We need the base specs that you're working to, the type of material, you got the grouping, and then you've got the thickness and things of whatever's happening. So we've got a WPS here, which is for titanium, because we're busy qualifying a lot of titanium procedures at the minute for our clients, right? So it's group 43, it's 3 mil thick, and it's in a pipe at 150 mil. So you can just imagine that pipe, 2 pipes coming together, and away we go, right? So then we've got our joint design information. So I'm saying I've got a groove here, and it all works. So I'll very quickly, if I go insert, I just knock out. Do you know when you know something's there and you cannot see it for whatever reason? Shapes. There we go. So I'm going to have a joint design that sits. I'll move these up a bit actually. Again, not laid out the way I would normally lay it out because I'm doing this very quickly. But what I try to do is add in an unwelded joint and then a welded joint. Like that. Okay? So I tell you what, I'm going to stick in one run and then I'm going to stick a run on the top just to give us something to talk about. Right. So I've got my 2 runs here, which I'm going to shape fill like that. Great. So we show the joint design it is. So this is shown as a square butt. And then we are going to put 2 passes in to fill it up according to the drawings, right? Now, one of the things to remember here is the WPSs you're given purposely have issues in them. They have to, don't they? Because we have to ask questions about it. So you can see we've already got a contradiction because we're showing a square butt weld here, but we're saying we need a groove angle of 35 degrees. Now, when you're looking through your document, don't worry if there's other things wrong that you have not been asked about. Who cares, right? It just means that in another exam, they might ask questions about that. You are only answering the question you are being asked, and that is it. Okay, so we've got that there. Then we've got some information about preheats and interpass temperatures. We've got a shielding gas information. So we've got our shielding gas and our purge gas, and then we've got a load of information here which doesn't help us. So what we're going to do is we've got areas for sizes. I tell you what, if I just delete some of these just to make it easier for us. I don't know, do we go like 20 to 120, something like that? Oh no, it's not where I want it to be. Just putting some in here, thinking fast as we go. Right. So we've got some information in our WPS, and then we have some. I always put on my WPSs some information about NDT, what's required, especially through PQR, so we can look at that. Then we've got our information about any reference documentation, material certs, etc., any notes, and then away we go. Okay, nice and easy, and we can kind of stop it from being an issue. Sorry, I've just moved that off as we go. Right, so yeah, there's it back again. All right, don't ask me to do anything unprepared because it's always a bit messy. Right, so that's our layout of the WPS. You will get several of these, at least 3, sometimes 4 WPSs to look at. you will get a question that says something along the lines of, I don't know. So your procedure, so question 1, you are required to qualify in the PF position. Does your WPS or WPS1, is the information stated in there correct? Right? So we've got a positional question saying that I've got to work vertical up. All I need to do is come to my WPS, look at it and say, this is my welding position here is PA rotated, which is a pipe where we're welding at the 12 o'clock position and the pipe is actually going to rotate underneath it and my welding torch is going to stay stationary. So is that correct or not? No, it's not. So we take the WPS is incorrect answer. Right? You may get a question saying, I don't know, you are required to have a square edge butt. Is this correct? Okay, go to our design. All right, we've got a square edge here, but no, it says we want 35 degrees as a bevel angle, so that's not a square edge. Done. It might then go and say, well, you are using a square edge butt. What is the likely defect to come from this this type of joint design? And then you've got to think, well, for a square edge butt, if it's too thick, we may not penetrate all the way through the material, because that's the whole purpose of a V, is to allow us to get into the root and make sure we get full pen. So which of these defects might occur? And you'd be looking for some sort of lack of fusion, lack of penetration type defect in your answers. Okay? So I'm trying to make these questions up as I go along off the top of my head, but you can see why this might be a challenge, because it's drawn in all of your knowledge from everywhere else. It's just laying it out as a question paper in a different way. Okay, I think one of the hardest things on the WPS paper is to do with heat inputs. Now, what I always do is put what the WPS needs to have, but in your answers, these minimum and maximum don't exist. Okay, they're asking you to calculate these answers from this information that's here. And this is a horrible way, and this is the incorrect way of doing it. Okay, you should never ever do this on a PQR. Right? You always use exactly what you've got on a line. An individual weld has one amperage, one voltage, one travel speed. That's a heat input. But this is just a way of getting you to do some heat input calcs. So when we're working out the minimum heat input for our root line, what do we have to do? How would we go about that? Well, we're looking to get the lowest number. So if we can remember our heat input calculation, yeah. So they might have asked you a heat input calc in your general paper, but this is a way of just doing it in a different way. So to get the minimum, we want to do the minimum amps, the minimum volts, and then we take our fastest travel speed and we work out the heat input. Yeah. Now, on my WPS, I have millimeters a second. So you might have to change that over depending on how you're doing your heat input calculation. Yeah. If we want to do, so that would be the minimum there. If we want to do the maximum, of course, it's going to be the maximum amps, the maximum volts, and the minimum travel speed, because that's going to give us the highest amount. Remember, travel speed overall has the largest effect on heat input, because in our equation, travel speed is the divisional number. It's underneath. So the smaller that number, the higher the overall will be. And that fits in there. Okay. Now, you might have to do it for both lines. You might only have to do it for one line. It depends how many questions they ask you. But just keep that in mind. Okay. And then we get to plow through and just do it like that. Like I say, it's a weird way of asking, but it's just their way of getting you to do some heat input calculations. But you never do it like this when you're actually making documentation. Okay, you look at your as run data and you take individual lines as a whole, and your minimum maximum are the minimum and maximum from your calculated as run data, not selecting an amperage from here and a voltage from here and so on, right? Okay, so you can do that, right? You might get a question, and I'm just looking at NDT, that says, I don't know, let's make this empty just for giggles. Okay, so we're looking at, in our non-destructive testing area, we say we're going to do 100% visual and 100% magnetic testing. Now, question to you, what is the problem with doing magnetic testing on titanium? Is there a worry for that? I know I've got a delay, so I'm hanging around. I hate this delay because I ask a question and I've got to wait for way too long. If anybody's still there, of course. All right. Right. So, where would my delay be? Well, the biggest thing with this is titanium is non-magnetic. So we can't produce magnetic testing on titanium. And we know it's titanium because we go back up to the top here. Oh, trying to click the wrong buttons. If we look at titanium, it's here, right? It's non-magnetic. It might be stainless. 316 stainless steel is non-magnetic. So my multi-choice question on this could be, MT is used. Is this the correct method? Well, no, because it's non-magnetic. And you can imagine just how many... sorry, I'm just trying to bring this up. How many different things and questions they can ask us around NDT could be. Yeah, Sean got it right. Non-ferrous. Yeah. So, again, imagine the WPS being a way that a lot of different general knowledge is pulled into one document. And a welder qual works exactly the same. It's just we're going to use a welder qualification page rather than the WPS, right? And we can hit it from there. Yeah. So does anybody have any questions with the WPS directly there? Right. While you're thinking about that, I am going to bring up a welder qual, and then we can have a quick look at that. I'm trying to find one that might have some errors in it. Okay. So when we look at a welder qual, here is our welder qualification. Right? Of course, laid out in a different way to that of a WPS. It's a different set of information in it in what we're doing. Okay, so what we have down one side here is we've got our actual values coming down here. So what we tested, and then we have our range of qualification. So most questions around a welder qual are going to be one of what is, does this welder qual cover the WPS we're looking at? So For example, with regards to welding process, does Welder Qual 56, this one, cover us to use WPS1? So you've got to look at Qual 56, which is this one, and you go, all right, okay. So the welding process here is MMA 111. Okay, right. Now I need to go back and see what the welding process for WPS1 was. So we come back to this one, and then we go, right, what was the welding process? Right, okay, it's manual TIG. So does welding with MMA qualify us for TIG welding? Oh, no, right, is the nice, easy answer. So that's that question answered. MMA, and how do I know it doesn't? Even if I can't remember what the standard tells me, remember there's a qualification range here. Okay, so it's saying MMA only. So nice, easy answer, tick, right? You may get some questions like if I zoom in here. So this is a 9606 qualification. So for those of you like Middle East, India, Asia, Far East, I know 9606 doesn't come up a lot. It's more ASME based. So in 9606, we don't give F and A numbers for consumables. We group them into filler material groups. So you can see here the coverage range is FM1, filler material group 1, and filler material group 2, right? And each filler material group tends to be in the type of material it is. Okay, so FM1 is what is carbon steel. I think I tell you what. Do you know what we're going to do? If you've never seen it before, see if I can boot up a copy. If this will open up one that I know I have. Oh, not that one. Of 9606. Give me 2 seconds. I'm gonna open a copy of it. Again, because if you're not used to these material groups, you won't know. So I'll just log into the system. And I'll get the most up-to-date version of 9606. Not the track changes. I want this one. Okay, so 9606. In here, we are going to have just try and bring this up in a way that we can actually see it. Right, FM groups, yeah. So 9606 table 2 gives us these FM groups. So FM1 is non-alloyed steel, FM2 high strength, FM3 creep resistance, and FM4 creep resistance, but slightly different mechanical properties in that, right? And then we've got our FM5 is stainless, FM6 is on nickel alloys. Again, different from the grouping systems of SAF numbers in AWS, where you'd have an F number and an A number. Like most TIG wire is normally in F6. Well, it's not the same in this one, right? But if you've never seen this one before, don't worry about it too much, because what we're doing here is just is giving you already the fall between it. Okay, so when we look at this document, we can see that we said it's an F2, therefore we're qualified for F1 and F2. Okay, so but this is only within 9606-1. Okay, so that's basically how it falls out. So it will say something along the lines of your welds need to be qualified for F5. It's a stainless steel as F5, M5. Sorry. Does this cover you? And you just come straight to your line and say, well, no, I'm only qualified for FM1 and FM2. If that hopefully makes sense. Just take your time through it as we go. Now I've lost all of my screens as I've been clicking around, so I'm going to try and find where I put you guys. But hopefully that answers the question on material grades. Don't worry about it too much. I can't see them asking you too many questions on AWS requirements for non-electrode types, because not MMA electrodes, because there's too much to remember. But we know that in the training material, they do ask a lot about MMA electrodes. Sorry, just trying to click around as I find where we are. Okay, so all right. Okay, so we've got some more questions here. Said ISO and the welder test qualifications at AWS. How do we? Okay, so sorry, of course I don't know the exam questions. The exam questions come up thick and fast and all the way around, so I wouldn't be able to tell you exactly what that question is. But generally try to see it as, is it qualified for the base material type? If it's a stainless steel and it's a stainless steel in both, you're probably going to be okay. But the direct comparison between AWS classification types and ISO classification types are quite difficult. Where they might get you to do that, again, is something in MMA where you can kind of tie together basic rutile and cellulosic between both specifications. So we spend a decent amount of time on this in the CSWIP training, is teaching you the AWS for MMA electrodes. So where you go through like E, 60, 10, 11, 12, 13, 15, 16, 18, and you pull down that, right? And then you can see in the ISO that it goes just basic cellulosic rutile B, C, R. So it wants you to be able to tie, oh, well, that one's basic, and then that one's basic, so I can use them. Because in a welder qual, that's what matters. It's not the mechanical properties of the electrode. It's the flux type, because that's what creates the difficulty of welding. So you're looking for them both to be basic, or both be cellulosic, or both be rutile. Okay. Right. So what we've got here. So just trying to know what the quality 606. Right. So we've got what? Please describe hydrogen-induced cold cracking. Okay. This is our next question. I'm going to bring up our whiteboard again. I'm just going to get rid of what we had on the last one. Okay. So, hydrogen-induced cold cracking. Right, we've done this to death, but it's always good to talk about it, and we can talk about many, many different things when we do it. So we need three things. We always need three things of hydrogen cracking, right? So we're going to do 1, 2, and 3. See how quickly I can I can hit this out on here. Right. So we've got our three things. Then we've got our you see this is a Venn diagram, so whenever any of these cross in the center here, we need all three things for it to happen. Some people view this as a triangle as well, which just hits the same point. So I don't care how you learn it, whether it be a triangle where you have 3 points or you do a Venn diagram, it doesn't matter, right? So we need 3 things. Okay, so we need a hydrogen level, we need a microstructure which is susceptible to cracking. Right, typing fast. And then we need our air stress. Even I can't remember what it was there. Right, and then in the middle, this is a temperature which is below 300 degrees Celsius. Okay, let's insert a proper symbol into that so we're all right. Degrees C. Okay, now I normally just put it out here and then stick an arrow in to say right in there. Right, so that's our. We say 3 things, but really it's 4, isn't it? Because it has to happen under 300 degrees, right? So next question is, well, how much hydrogen do I need? Well, we need greater than 15 milliliters of hydrogen in our weld. Now, the question for you is, where does that hydrogen come from? Okay, we need a stress which is greater than 0.5 of the yield. And we need a microstructure, okay, which is likely to crack. Okay, so if I give you them, I need you to think about what will cause these things, right? And next to it, what you do is you just take this and you say, okay, where does my hydrogen come from? Hydrogen comes from damp electrodes. It might come from contamination of shielding gas. It might come from what? Unbaked electrodes. And go down and just hit it all. Oil, water on plate, all of that type of thing, right? And that'll give you everything that's to do there. And that list is pretty big, okay? You can then come and do the same for your stress. So it'd be bad fit up. So, you know, bad misalignment in the plate. Thermal stresses, etc. Okay, right, so you want all that, and then you want your microstructure. So the biggest thing for microstructure is always fast cooling. Okay, again, I love a TTT diagram, right? If you haven't watched our video on TTT diagrams, go and watch it, because this is probably the biggest thing which is going to affect hydrogen cracking. Okay, I'm not going to explain it all now, but because we've got a video on it, go and watch it and then ask questions in there and I can answer them, right? So fast cooling is definitely going to be that. It might be that it's got a high CV, carbon equivalent value, okay, because that affects the TTT diagram and affects the creation of martensitic structures, right? Then, once you've done all that, think about how you stop this. Now, in the main, we use one big method to sort of correct most of this, which is going to be preheat, right? Preheat and slower cooling rates, because what's going to happen here is that the preheat warms the plate up. It gets rid of some of the moisture on the plate, but it's not the main reason. Right? It changes or levels out a lot of the thermal stresses because we don't have hot metal right next to cold metal. Right? It's going to slow the cooling rate, so it's going to change our TTT diagram away from martensite. Yeah, and it's going to keep the material above 300 degrees for longer to let any trapped hydrogen dissolve out or diffuse out of the weld metal, right? So preheat is the biggest thing that's going to stop this from happening, and it's probably the least controlled thing when we're on site. When we're on site, how many people actively really control preheat? We kind of pretend to heat it up with a gas torch. We quickly check the preheat value, and then we disappear. Okay, and this is one of the things we could then tie that back to our PWPS. If we come back to our WPS questions and say, well, where on the WPS do we control or put controls in for hydrogen cracking? Okay, so we've just said preheat's going to be the biggest thing, so we can come down to here and go, right, I need to look at how this is being used. Okay, and you might get a question that says the CV in this material is really high. Is the preheat value sufficient to stop this from happening? And you might look at this number here, the recorded preheat, and it be, no, it's not, or yes, it is. And then you can go from there, right? So you can say the WPSs, going back to that, tie in all of that knowledge elsewhere. They're not separate from the knowledge, so don't worry about it too much. Okay. Again, we've got a video on hydrogen cracking, which allows us to go through it in a lot more detail. Go and have a look at that and ask your questions there if there's anything more in detail we need to cover. Okay. All right, where are we next? Questions said. Okay, how do we relate welding position? Okay, so Eric's asked a question here. How do we relate welding positions per 9606 to ASME 9? Right. There isn't... The two systems for ASME and ISO are based on a fundamentally different way of looking at the problem. Okay. I am going to just bring up my my whiteboard again. I don't like the ASME way of doing welding positions. It's just I know it doesn't matter what I like, and you know nobody's going to listen to me on it at any of these boards, but I think the ISO way of doing this kind of deals with a challenge quite well, right? So for ISO, the best way to think about welding positions is to draw a box, an open-sided box like this. Okay, you might have been shown this when you've been doing your courses, but I'll just run over it quickly. Right, imagine this box and we are standing here like that. Yeah, I was that skinny once. Right, so in our box we're going to put some welds. Now the first one would be at this position here, going down. So that's going to be our position A, right? And this is why I like ISO, because it's just position A, position B, position C, right? And then we start heading around it. So if that's PA, imagine that being like two plates coming together there. Position B is here. Trying to write with a mouse is very difficult as always, right? Position B is into this corner. So what type of joint is that? Well, position A, we can see, is a butt weld. Okay. Position B is a fillet. Okay. Fillet. Get the E on there. Right. There's our fillet weld. There inherently is the biggest difference between ASME and ISO. That in ISO, we pull everything together into the same numbering system. So A, B, C, D, E, F, G, right? Where ASME have them in two different groups. They have 1G, position 1 groove, which is a butt weld, and then 1F, position 1 fillet. And they don't merge very well. Okay, so our next one is PC, which is this horizontal. So PC. Again, you can see by the type of joint it is, that's going to be a butt weld. Then we've got into the top here, because it's above where I am, so PD. That is our overhead fillet. And then we've got PE, which is our overhead butt weld. Okay. So again, we can just, by saying PD, I know it's an overhead fillet because I can draw this out in a way I go. And then we can say, well, which joint designs us for which type. So this is, again, I think it's one of the training questions for CSWIP on the WPSs, where it says, which of these welding positions is not covered? And when you look at it, I think it's a butt weld procedure, and it lists like PA, PC, PE, PD, and of course PD is a fillet weld, and when it's a butt weld procedure, it's not really a stated coverage range. Okay, so we get that, and then we have our vertical up, which we draw like this, and our vertical down, which become our PF going up, and then PG. So it's in direct answer to your question, Eric. The answer is you just have to learn both systems. They don't tie together well, but this is ISO is a fairly logical system that we can plow out and understand. Okay, I guess you could pull some of these together, because you could say, if I change the color here, well, PA is a 1G, yeah, because it's position 1 groove, and then go through that and make your own way of tying them together by looking at the ASME requirements and then the ISO requirements. Yeah, okay. Right, what question we got next? Can you discuss the range of factors recorded and providing some examples for these ranges? So Lam has asked for ranges and WPSs. Now, the ranges we put into WPSs are very much dependent on the standard we're using. So, for instance, ISO concentrates more on a range for heat input, but not for amps and volts and travel speed. Your amps, volts, and travel speed can be whatever they want to be, as long as your heat input falls within the range that the standard tells us. And ISO splits that range by talking about toughness values and hardness values. So if we're worried about toughness, you can only go up a maximum of 25% on heat input. And if we're worried about hardness, you can only come down 25% on heat input. So let's say we're worried about hardness, but we're not worried about toughness. You can come down 25%, but up to unlimited, and vice versa. Where some standards like ASME 9 write physical percentage values like 5 and 10% into the ranges for amps and volts in a different way. So you just have to fall into whatever the standard says and apply them from there, really. It's every standard looks at it differently. Okay, and then some standards, even in ISO, just don't question it at all. Like, I've got a feeling the titanium one, so 15614-5, doesn't even have a range for heat input, because titanium, we're not worried about the effects of carbon because it doesn't have any in for hardness or toughness. And it's just like, yeah, do whatever you want, really. Test it to make sure you can produce a weld that's very, you know, at least meets a set of requirements, and you're good. What we got? So Freddie, sorry, just joined. I have a question. Let's say a welder was qualified at 9606-1 with a welding procedure that was qualified in ISO. For that 6-month confirmation of value, does the welder, need to have done that ISO welding procedure in the last 6 months? Right. So the welder has to have used the qualification in the last 6 months. So if I have 2 qualifications, both in TIG welding, I don't know, one's for 1 mil to 10 mil thick, and one's for 10 to 20 mil thick, right? And in the last 6 months, I have only been using my 1 to 10 mil. Yes, I will lose the 10 to 20 mil qualification because I haven't proved I can do it. Yeah. I know that the ranges I've just given you aren't ranges within the standard, but it's just for the example. And we get to pull. ASME used to do it a different way, where it was like if you just use the process, everything can be prolongated, but that's changed now. So yes, the welder has to use each qualification within the 6-month period, which is a challenge when we have welders who have multiple qualifications. You always need them just to do a single butt weld or something like that to get it x-rayed, to get your volumetric requirement and move on. Remembering that the standard talks about volumetric requirement is a test result as evidence. So you've got to get that to sign it off. What's the difference between preheat and interpass? Right. This is going to have to be my last one. I need to... we're doing water safety tests today for sea cadets, so I need to go and get ready and get my wetsuit and everything sorted for that, and be in a river freezing for the rest of the afternoon. But we can finish this one off quite nicely, right? So if I just rub this, I'll just get rid of this on here. Thank you for everyone who's turned up today as well, you know. Again, ask your questions in the videos. It really helps the engagement on the videos. If you have any questions, just drop it in. I am desperately trying to hit as many of those questions as I can when I see them. YouTube doesn't always tell me straight away when someone makes a comment, and I find that I have to go in and check them manually to see where we are. Right. So when we talk about preheat and interpass temperature, the way I like to think about it is, imagine a straight line, and we've got, which is temperature, right? Temperature in degrees C, right? So we've got our max temp at the top, and we've got our minimum temperature at the bottom, right? Okay, what we need to do is to produce a window in which it's sensible for us to weld within, right? So the first one is, what temperature does the plate need to be before we start welding, right? So that is our preheat. So that's going to be our minimum temperature, isn't it? So what I'm going to do is put a line on here and say, right, this here is my preheat, right? Right, so I've got a preheat temperature here. Preheat temperatures change depending on what we're doing, okay? It's, you know, the material, so the CEV of the material, the thickness, you know, all sorts of things. Each standard looks at it slightly differently. Some standards just say, like AWS D11 just says, if it's this material thickness, here is your preheat value. BSEN 1011 gives you these questions on combined material thickness, CEV, etc. Okay, heat input is one of them as well. So, so preheat value. So let's just say our preheat is going to be 80 degrees, right? So there's our temperature that we can't weld beneath. All of this, if we're below 80 degrees, we're not allowed to weld, right? So that gets us started. That's going to make sure we don't have a too fast of a cooling rate. Now what we have to do is to work out what is the maximum temperature we have. Now, in reality, what we've got is a weld arc at 6,000 degrees, materials melting at 1,500 degrees. So it's hot, right? But when we stop welding and we go to restart, we need to be below a temperature. And what that's doing is making sure we're not just cooking our plate and constantly making it hotter and hotter and hotter, which would affect the toughness values. Okay, so preheat is affecting hardness, interpass is affecting toughness, really. Okay, so what we're then going to do is we're going to put a line across here and say anything above this line we're not allowed to weld. We have to let it cool back down to then weld. And this is our interpass. Yeah. If that's our interpass, there we go. Now for carbon steel, when we don't know, we generally pick 250 degrees. And you've probably seen that on a lot of WPSs. It's like, I don't know, I'm going to take a guess, 250 degrees, right? But in reality, that comes from the qualification sample. And then we get a range. It's like plus or minus 55 degrees Celsius, right? From whatever we tested in the PQR. So that means I've now got my upper limit and my lower limit to which I'm allowed to weld in here. So when I start the day, I have to preheat it above 80 degrees. And when I'm welding, if I finish doing a weld run and put my probe on it and it reads 400 degrees, I've got to stop, let it come back down, and once it's under 250, I can start welding again. So that's your preheat, and your interpass temperature between runs is done. Now, if I was to stop for my lunch break or for the afternoon and go home, come back the next day, of course, I'm starting welding again, so I'm back to my preheat to heat it back up and then stay between them lines. Okay, so hopefully that made sense. Yeah. And of course, different materials will have different preheats and interpass temperatures. 80 and 250 are fairly common for like 50 mil carbon steely type stuff, right? Some materials, it doesn't matter. Yeah, they don't get affected by these things, and you do whatever you want. But the standard will tell us what we have to do. Okay, great then. So thank you all. It's been a pleasure. I love speaking to you. You know, I saw a few of you at the WGS dinner. A week ago now, which was great. If you ever see me, just give me a shout. Come across and we'll have a chat. Yeah. And we go from there. So yeah, I will see you all later. Have a brilliant weekend. Stay safe and good luck with your studies. Bye bye.